this is video 611, and the goal of this video is to be able to talk about the ambiguous case of side-side angle, so that naughty word, that case that is going to cause problems when we're trying to find missing information. And we're going to take a look at that and summarize it here, so you'll kind of want to jot a couple of things down, if not the examples. So the ambiguous case, so we're going to take a look at what could happen when we're given the information side-side angle. So that means that we're given the angle, and we're given a side across from it, as you can see here. And then we're given another side, either one, that is next to that angle. So this is side, 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 because side, side, angle, side, side, angle. Now what happens is there's some cases that, one case that's really easy. If the angle we're given that's across from the side is bigger than our other side, so A is bigger than B in this case, then only one triangle is possible. But this is only true if A is also bigger than H, okay, longer than the height of the triangle. Then this gives us one single triangle. So if we're given this case, we can kind of assume and go in the direction of one unique triangle. So that's the easiest case. Now then there's the other cases where they're kind of more ambiguous and there's more opportunities for issues. This is the case now where A is less than B. So the side that we're given that's across from the angle A, across from angle A, is smaller than the other side B that we're given. This case can either form a right triangle like you see here, but it can do two other options. There are three options at this case. It could either be a right triangle, and we'll find that out when we solve for the missing angle. It could make no triangle. Again, we'll find that out when we're solving for the missing angle. Or it could solve and make two possible triangles. So this is the case that we will have to be a little bit more careful with. So this is the triangle with a right triangle. That's where A is exactly the same as what the height would have to be, and it'll make an exact right triangle. Or maybe A is too short and it won't make a triangle at all. Or maybe A could be swinging and swing in or out and make two different triangles. So let's talk about, at least we'll see some of these here in these next examples. So in this first example here, we're given a triangle with exactly this side-side angle. The angle side, the side that's extra is side C that's next to the angle. And we have to figure out side C, angle C first here. Notice that side A is larger than the other side that we're given, side C. Therefore, this only makes one triangle, because it's that first case that we saw on the previous slide. So we'll set it up as law of sines. Sine of 81 over 20 equals sine of C over 12, and we'll solve for angle C. Now in solving for angle C, we start by timesing both sides by 12. And when I punch that left-hand side into my calculator, I get some decimal. I like to leave that decimal in my calculator so now I can find this angle C, because all we did was solve for sine C. Now we're solving for angle C by taking the sine inverse, checking to make sure we're in degree mode. Sine inverse of that value is going to give me an angle of 36.34 degrees. So I'm going to add that to my picture so I can kind of see where that's at, and then go from there. Now the instructions said to find angle B and side B. So let's start with finding angle B, since that's the easy one, by taking 180 minus the angles we're given. And we end up getting 62.66. Now let's take a look and find side B by setting up the law of sines one more time. I'm going to use the one side that I know for sure, the 81 and the 20, because that's exact. I'm not going to use the missing angle that I just found, the 36.34. Now I'm going to set up and solve for B by cross multiplying and dividing and so on. And I kind of skip through that step because I think it's rather easy at this point to solve this ratio. If you don't know how to solve for 17.984, you'll want to ask me questions in class. Now let's take a look at solving another type of problem where now the side length is shorter. The side length across from the angle is shorter than the other side length. Since it's smaller, therefore there will be 0, 1, or 2 triangles, and that one triangle would if it was 90 degrees. So I'm going to set it up and solve it just like I did the previous one, but I'm going to keep in mind that this might be the ambiguous case. Solving for sine of B, I get 1.116. Now here's the issue. Sine can never be greater than 1. Think of your unit circle. The sine is never greater than 1. So this makes no triangle. This triangle does not exist. So I cannot find angle B because this triangle does not exist. So this will never, that's when you'll find no triangle, when you get a sign that cannot exist. It's typically sign is greater than 1. A negative sign is also problematic because you'll end up getting an angle that's bigger than 180, which cannot make a triangle. So keep that in mind as well, and we'll keep an eye out for that in class tomorrow. Let's take a look at an application. So we've been doing this application problem. So for class tomorrow, I'd like you to draw the following picture. Draw the picture. We've seen this problem before. This is on one of your quizzes. Draw this picture for class, and then think about how we can use the law of sines to make this problem go a little bit faster. What could we do to set up this problem and speed things up and solve for the missing angles and sides? Your free response questions are to solve the following 2 problems. So you have is to find the length from point A to point B. That's your free response question for this video. And your multiple choice question is to answer the following questions. So see if you can set up this problem for this picture and find out if there's only 1, 0, 1, or 2 or more than 2 triangles for the following picture. Good luck, bring those questions in, and thanks for watching.